VRPERMTEST is a new Genstat procedure that helps you to assess the importance of random effects in a REML analysis. It was first introduced in Genstat 18. VRPERMTEST implements a pair of permutation tests to assess whether a random term can be dropped. One test is based on the best linear unbiased predictors, or BLUPs, and the other one is based on the residual likelihood ratio test statistic. The likelihood ratio-based approach enables the simultaneous testing of multiple random terms, whereas the BLUP-based approach can only be used to test the significance of dropping a single random term. The procedure is based on the methods Lee and Braun proposed in their 2012 biometrics paper. The key to the method is permuting the weighted marginal residuals. The weights ensure that the marginal residuals are exchangeable under the null hypothesis. Let's have a look at VRPERMTEST. First, we'll demonstrate VRPERMTEST using the commands. Then later in this video, we'll show you how to do the same analysis using Genstat's menus. There are two options and one parameter that you must set when using VRPERMTEST. A model definition structure defining the full model must be supplied using the model definition option. Model definition structures are created using the VF model procedure and, if required, the VF structure procedure. VF model defines the model settings controlled by the V components directive, and VF structure defines the model settings controlled by the V structure directive. You must also specify the random term or terms to be dropped from the full model using the RDrop option. Finally, you must specify the variate to be modelled using the Y parameter. Other options and parameters control what output is generated, the graphics produced, the random permutations made, and results that are saved. Let's demonstrate VRPERMTEST using the Slate Hall farm field experiment. We'll fit an initial model to the yield data, comprising a fixed term for variety, an AR1 by AR1 spatial model across the field rows and field columns, and additional random terms for the measurement error and the replicates. VRPERMTEST can be used to help select the random model. For example, let's assess whether the measurement error term plot number is needed in the model. First, we must define a REML model definition structure for our full model using the VF model and VF structure procedures. Here, the resulting model definition structure is named full model. Now we can call VRPERMTEST. Set the model definition option to full model, the RDrop option to plot number, and the Y parameter to yield. To get a histogram of the permuted test statistics, set the plot option to histogram. A kernel density plot of the permuted test statistics may also be requested. We run this code to assess whether the random term plot number can be dropped from the model. This may take a moment as the random permutations are performed. As we haven't set the seed to a non-zero number, we'll get a different set of permutations each time the analysis is performed. 160 permutations were tried, of which 99 were successful. As only one random term is being dropped, both the likelihood ratio-based and BLUP-based permutation tests were performed. Under the null hypothesis, the variance of the plot number random effect is 0. Here, as the p-values are small, there is evidence that the measurement error term, plot number, should be included in the model. Histograms of the permuted BLUP-based test statistics and permuted residual likelihood ratio-based test statistics are displayed in the graphics viewer. The blue line indicates the observed test statistic. In both cases, the permutations have resulted in only a few values that are more extreme than the observed test statistic. Let's now see how to perform VRPERMTEST using the Genstat menus. Open the Linear Mixed Models dialog. We'll replicate what we did before. Fit the initial model to the yield data. Select Variety for the fixed model. Enter the model formula into the Random Model field. Now select an AR1 by AR1 spatial model across the field rows and field columns. Run the analysis and check the output. As before, let's assess whether the measurement error term plot number is needed in the model. Bring the Linear Mixed Models dialog to the front and click Further Output. Now click Permutation Test. Under the Random Term to Drop from the Model drop-down list, select Plot Number. The options in the Display section control what output is displayed. By default, a summary of the test results is printed. However, error diagnostics and monitoring information can also be output. The Plots section controls whether kernel density plots and histograms of the permuted test statistics are generated. We'll select histogram as before. In the Permutations section, we can set the number of permutations to perform, a limit on the extra number of permutations to perform when there are convergence issues with the REML model, and the seed for the random number generator. Using the default seed of 0 means that a different set of permutations will be generated each time the analysis is performed. Let's retain the default settings. Finally, the Results section enables results from the permutation tests to be saved. Click Run to assess whether the random term, plot number, can be dropped from the model. Note that the results here are slightly different from the earlier analysis, as we've used the 0 seed. This continues the sequence of random numbers from the previous generation. If we had used the same non-zero seed in both analyses, we would have got the same random numbers and hence the same permutations and results. As shown here, VRPERMTEST provides a useful tool for assessing whether a random effect can be dropped from a linear mixed model fitted using REML. However, random terms involved in the allocation and randomization of the fixed terms should always be included in the model. This is because excluding them will result in the wrong denominator degrees of freedom being used in the tests for fixed effects.